Anyways, well, so I think I'm going to start. Welcome everyone to at least for this semester, my first one on how can artificial intelligence enhance or hinder sustainable mobility. Welcome to the Sustainable Mobility Forum. So first off, here's who I am. Those of you who don't know me, I'm the chair of the Institute of Transport Planning and Traffic Engineering in Darmstadt. I'm also an adjunct at Michigan State University, where I actually currently am located here. I'm on my sabbatical. And teaching wise, I'm really interested in everything that has to do with mobility, traffic, transportation, but always in connection of major changes that are coming up. So, for example, now I'm focused on artificial intelligence, which you'll see in the following presentation. But I'm also doing a lot of on other extreme events like pandemics, how it affects transportation networks, or the Olympic Games. And of course, as a professor, I'm always interested in how students learn and how we can teach better. Generally speaking, I'm always at the intersect of transport technology and human behavior. So what am I showing you today? Today, I would like to give you some insights into a project that I won a little less than 2 years ago. It's called Urban Science, science spelled with an AI. So it is a new type of science in how AI transforms our world in general, and specifically how it affects urban areas, and more to that in a little bit. And then I give you a deep dive into autonomous mobility. That's a study I've done actually here in the US in terms of how people would like to travel in the future. So, what is AI in the city? So, if you think about a city, traditionally speaking, and what we're hearing a lot from the media right now, or also in a lot of things we hear, is AI is better for everything. And it will make us more sustainable. It will help us beat major challenges like climate change, energy crisis. But we were wondering whether that actually holds true because a lot of the things we read weren't really underlined by data or evidence. It was more, we think this is going to work and we'll implement it. So we set out to say we would like to measure this on the urban level. So for cities, does it actually hold true? And so we proposed this novel theory saying how and why AI influences our cities, our world. And we proposed it to the ERC, the European Research Council, and I was awarded a consolidated grant a couple of years ago. And the main research question was basically asking, can technological change lead to a better, more sustainable life in our cities? And how is AI transforming it? In order to do so, we had basically three major areas. We needed to look into governments, like to what rate and which type of AI are actually implementing on the local level. And we're looking about at the past 10 years to ask, what have you implemented and how has it worked? And we do so by doing phone interviews with local governments, but we are also web scraping web pages, plans of cities, implementation of cities for the implementation of artificial intelligence and smart cities too, because that was kind of the start of this entire movement. The second major area, we are looking at companies, and we'll do so over the 5 year period. We are basically or in it now. And we're doing a pre-post study asking companies what they're currently implementing, whether they have any plans to implement, and how this has worked for the companies on the local level so far. So we're trying to even take global companies, ask them for local implementation, and try to measure that in the city. And the third area is basically people living in those cities, residents, citizens, and we're looking more towards the future. And in doing so, we do two things. On the one hand, we have e-town halls. So that's basically a town hall where different people get together, discuss a topic, get presented with a topic, and we lead these discussions in terms of, would you like AI to happen in your city? If so, how? And the second area is a game. It's an online gaming system, more like a treasure hunt where we have participants, and you can do so too if you like. We can send out the link. You basically walk through a virtual city, and there's 17 stations. And in each station, you are basically being asked whether you, well, it's not necessarily 70. It depends how many stations you choose, but they're aligned with the Sustainable Development Goals. And you choose whether you would like rather AI to help you with your decision, or you would rather rely on only traditional methods in terms of whether you're solving a concurrent problem that is affecting that Sustainable Development Goal. So we started off like every good study with a literature review, and we searched in all these three areas again, so governments, industries, and people. And we were trying to ask them or look in the literature for how is AI actually impacting government or the public sector? How is it impacting companies? And how is it affecting, generally speaking, citizens or residents of the world? And so we followed the PRISMA method and ended up analyzing close to 500 articles. And we looked specifically for what type of AI, so which use case, how is AI being used in that city? We looked for, is there any mentioning of sustainability in one way or another? Can we cluster it to a certain sustainable development goal? Then we looked at an impact. So this was a judgment call by us. How is it scored? Is it positive, negative, to what extent? And we used a 7-point scale from -3 to +3, a 0, of course, included. And then we looked at what's the implementation status. So we specifically looked at, has it been implemented or not yet? Is it just a plan? Then we looked at how is it measured? How do you measure success? And then in a narrative analysis, we were trying to take a look at, is it based on empirical data? Did they actually measure it? Or is it rather, okay, we have a feeling this really improved our flow. And so we went through all of those steps in the literature review, and here is what came out of it. So in terms of governance, we had only one, that means SDG 10 basically said we had reduced inequalities. So basically what it means, the more AI was being implemented, the more unequal it seemed to be. But generally speaking, overall, the average impact of AI on the Sustainable Development Goals were positive, especially so the governmental literature basically reported it was quality of education, clean water and sanitation, and responsible consumption and production were the three where they saw the most improvements. The negative impacts were more focused on the fear of curbing citizens' rights, replacing employees, and creating biased recommendations. What stuck out to us was when we read the governmental literature was that only about 10% of AI was actually being deployed in cities. The other 90% were more hypothetical or plans and assumptions based on the literature only. Then we looked at AI deployment by companies. Here, what struck out is that between the three, companies by far had implemented the most artificial intelligence. And we see here again the same SDG 10, so the inequalities increased, gender equality decreased as well. But the others, again, were primarily positive. They were looking at efficiency gains, primarily looking for profits, and companies in general had about 90% already implemented of all the AI use cases we could identify. Then we looked at, of course, what are publications regarding people? Well, how do they see AI? So here we also recorded that the average impact was primarily positive. In that sense, we had especially good health and well-being was there, sustainable cities and communities, and we saw only slight increases in peace, justice, and strong institutions. And here, positive AI especially were cited in healthcare. I want to point this out because later on I would like to talk a little bit more about this one, as in another study I had found that especially healthcare and education, people not necessarily were preferring AI simply because it was a lot of privacy concerns and data protection that they were afraid of. So how does that have, what does that have to do with transportation? So here we extracted the part on transportation, even though our study was very general and broad. We looked into what happens in transportation. So here we saw especially strong usage in accessibility analysis, optimization of network. We looked at traffic flow modeling and traffic signal optimization. So essentially everything where you're looking for efficiency gains. You are trying to identify patterns and you have large data sets. That's when AI was most used in those cases. The second area where we identified AI usage was incident detection. So here we looked at basically image analysis, where it was used for traffic management, incident response, or in general mitigating congestion. That's when really AI and image analysis came into play in those areas. Then we had predictive models where it was used as number three. Here they were trying to use and predict traffic flow. So again, AI is very strong in recognizing pattern, very strong in recognizing history. So here, in order to reduce congestion or look for energy consumption options, AI was used. The fourth area, what we saw pop up was shared mobility. So here again, you have optimization problems where the distribution of resources was measured by AI. It was looked for traffic savings, so time savings when you had congestion, but also we saw every now and then the use in pollution reduction. And last but not least, this is where I will spend the second half of the talk about, is intelligent urban mobility. So there we see slowly but surely the idea of actually making autonomous vehicles a reality in everyday life. So in generally, we had, per the literature, saying we have positive impact generally across transportation and greater efficiencies. So here we're looking at optimization models, be it scheduling, routing, or predictive maintenance. We had, generally speaking, a positive connotation from the literature that said we can record increased passenger satisfaction, higher quality of life. And we said we saw a lot of traffic flow management impacts that resulted in a better flow, reduced emission, reduced fuel consumption, and generally speaking, better air quality. Negatively speaking, the literature pointed out that there were concerns about privacy and, of course, cybersecurity. There was a tendency to say there are now jobs being displaced in transportation and logistics sectors because you have AI. Then what we've seen, and you've seen this in the previous slides too, we had equity concerns because you're drawing from historical data and novel equity concepts weren't quite captured. So you had, of course, the digital divide. So who has actually access to the apps, who has access to the web? Can they bridge that divide as using AI? So they couldn't. And then last but not least, AI is very energy intensive. And so here there was a fear that it might offset some environmental impacts and benefits. In the next section, I'm going to introduce you. So this was what the literature said. Now we're saying we're actually going on the ground. We would like to measure what AI does in cities. And you see here a map and an extract of 20 cities that we selected as a pilot. That being said, we've identified across the world 343 cities where this case study will take place over the next 3 years, where we're identifying basically each one of those. So those who've recognized the pattern, one of those cities is the capital of the country. And the second one is, geographically speaking, the opposite of that country. So, for example, if you would pick a capital city and the capital city is located inland, so not connected to a major body of water or, of course, the ocean, most of the time we took the ocean, then the opposite city is a city that is located along the ocean. So that was our pattern that we selected in order to see whether there's a repetitive pattern. For example, in capital cities, you would assume you would have more access to funds, more access to AI because it can be funded. It's the government location. And then looking at a different city to see whether the economic input into the city would possibly change it. So these were the cities. And so far, It's the current, literally from a week ago, that's the current state where we're at. We're now conducting our 3 work packages. So as a memory, the first one, interviews, that was more government. So we're looking at governance. You can see how far we've come in terms of whom we've interviewed. Then we have our pre-survey running to those companies. And we have in the last column the people where we've conducted e-town halls so far. And here's what we found. So the comparative case study in government has so far analyzed 6 cities, and it's very spread around who actually implements it and who doesn't. We have seen some AI cities, so my PhDs decided to cluster them in AI and non-AI cities. That means AI cities are those who are very open, who've started implementing AI, and non-AI cities who are rather relying on traditional methods to increase sustainability. And so here's basically 2 examples. Tunis has focused primarily on basic urban management, and they basically decided, okay, we have resource constraints and can't implement it. We are only at the early stages of digital transformation. In order to use AI, you need excessive data sets, so they are starting to. And Northern Buri basically said, we're looking at the coexistence between urban and rural, and we're trying to bridge the gaps with traditional methods. Then we had cities where you could see more and more AI coming into those cities. So here we've clustered 4 so far, and they are really spread around. On the one hand, mobility. We saw a lot of implementation around crime detections, and sustainability is also bolstered in terms of non-AI methods and traditional methods in urban planning and transport planning to implement the SDGs. Bangkok, Yaoundé, and Monaco, same, where we would say Monaco is probably the most advanced in AI integrations, and they saw positive outcomes in efficiency and safety, and especially through the use of real-time data. So how does it look like specifically for transportation? So we picked the 4 where we saw already AI implementation for transportation. So again, we saw they were implemented in traffic management with the goal of reducing emissions, reducing congestions. We had monitoring of image analysis in Bangkok, in Islamabad, the same way. The monitoring of installation of cameras, analysis through AI to improve mobility and traffic flow. Yaoundé as well. Here we saw more safety projects, so the quality of life increasing more and more due to better safety regulations. And then we had in Monaco, as we would feel this is the most advanced, we had started to see predictive planning and enabling efficient mobility strategies within the urban transport setting for transportation. Then we looked at the companies, and we looked at those in terms of we take across those cities. So far, companies have responded in 9 cities. And what we're seeing here, especially, is that AI is boosting efficiency, improving the processes of in cities, be it urban management, and they reduce especially repetitive tasks where the pattern can be easily identified. Most of the AI use cases were really only industry focused. Very few had broader societal objectives. And again, gender equality, there are some that weren't mentioned, but here we have a case where inequalities were reduced. Then what did we look at? We looked at, picked 2 cities for now. We looked, for example, into Barcelona in Spain and looked at what is it used for in transportation. And we again see image analysis, so video analytics that detects, for example, someone who wants to avoid paying fares, jumping a turnstile, looking at public transport access to watching out for not overcrowding. And generally speaking, it was rated positively on our SDG 11, Sustainable Cities and Communities. And then we looked at Karachi in Pakistan. Here, primarily, they looked at transportation insights, also automatic signaling in real time, and we had a lot of the most positive impact on industry innovation and infrastructure. When we are talking about attitudes in transportation, so that's again the people's perspective, we had support, generally speaking, for AI implementation. Here you can see about 48% supported in general, overall, and only very few oppose or strongly oppose it. What we've seen is the more AI had been introduced in the cities, the more supportive people became of those AI implementations. We asked the same questions in these e-town halls before and after they had the discussion. And here we saw that the process of an inclusive discussion about AI can shape AI acceptance, and it's always moving towards more acceptance of AI when people actually talk about use cases and discuss where it should be implemented and where not. So how does it look like in selected domains? So in urban planning, generally speaking, when it was implemented, it reduced cost. That was the most cited information about why we would want AI in urban planning. We saw in simulations and transparency, so for example, chatbots, that we could see more and more people got their answers faster. But then again, the concerns about you're excluded if you don't have access to a device, you're excluded if you can't get your voice heard through the pattern recognition in the history. And then one of the concerns, because that depended on our case study, is that the city simply hasn't produced, in quotation marks, enough data or correct data, or cannot produce it because there's not enough internet access or not enough data is being collected. And so the decision making of AI is very limited based on what was able to be collected. Then the question was, would you like to have AI in emergency response? Here we saw strong support, especially because the impression was that it could save lives, it could speed up the process, and it increases efficiency. And here, the emergency response part was not supported when it came down to basically emotional need for humans if they were in an emergency. So there, humans would be way better placed to support. And again, there were infrastructure gaps in terms of accessibility and who can actually have that emergency response. So if you think about cities who have large informal settlements and you can't get even emergency vehicles in, so there's a large population group that wouldn't be even detected because it's informal and it doesn't have the infrastructure to actually communicate that need. So how do we look at overall? So I mentioned the game before that everybody in the world is basically free to play, and we divvied it up by SDG. And as you can see, most of them have a very even distribution of people choosing whether they would like to have AI support and whether they would not like to have AI support. Choices are about, yeah, almost 50-50. AA was favored in peace, justice, and strong institutions, so rather in the governmental branch. We had sustainable cities and communities, so the main focus of that proposal where it was favored. In contrast, younger participants and women leaned more towards AI than other demographics. And that is a very interesting shift. So please keep that in mind as we move to the second part of that presentation. So how do people change in terms of transportation? What are their attitudes? When we are looking at that, again, we have about a 50-50 split. They are cautiously optimistic, non-optimistic, but especially in cities where we are looking at how do you actually use our image? How do you use the data? Is it trustworthy? And so you see a lot of balance in people's behavior, whether they would like AI or not. So here's so far our first clustering of the cities where we're willing to put into a into a matrix of saying we think more AI makes them more sustainable, less AI makes them more sustainable, or we have no AI and it's less sustainable. And so here's where we are still working on measurement metrics, where we integrate basically people, government, and industry perspective. So where are we at? We're looking again at our three pillars, where we're saying when you see we have it rated in terms of what do people are concerned about, but also where would they like to see it. Again, higher acceptance is within the people sphere when they've actually seen it, like when they've seen how AI works, not necessarily when it is a black box. So they are more abstract thinking, which is actually quite common in technology. Then we're looking at the concerns about trust. Do I want to be surveilled, and how does it actually affect equity? And there we are looking at demographic splits, we are looking at gender splits, we are looking at historical and new development splits. And generally speaking, there's some optimism towards whether AI can actually help solve our problems if, and that's the very big if it's used in the correct way and used in a transparent way so people actually understand how, for example, government would deploy it or how industry deploys it. Then we have our governance perspective. So here we see a lot of reluctance in terms of employment when it comes to resources, because for cities, resources are always very scarce. They're looking at the technical capacities of can we actually implement it, and if we implement it, what is actually being measured in those cities. Then we are looking at which government uses it, and generally speaking, the feedback we received was we cautiously use it, we monitor it. And then we have, last but not least, industry, who is very basically plowing through the past, very rapid adoption of artificial intelligence. We're looking at the area primarily industry, innovation, and infrastructure, though these three areas in terms of the SDG 9. And there's very limited knowledge about environmental and social goals. It's really primarily economically driven. So what is our limitation? So far, we have a relatively low response rate, especially in industry. That's fatigue. Plus, it's not really in their profit margin to actually respond to our survey, but we're trying our hardest. Then we have the online-based metaverse methods are very difficult to engage, especially for the elderly and those without access. So here, you can't play the game if you don't have internet access. You can't play the game if you are unaware of it. So we're very much working on getting the word out that there's a game you can play. And then we're looking at how do we actually get more people, especially those we don't have data in, how do they get their voices heard in this study? So that's another strong focus that we still haven't figured quite out yet, but it's becoming very evident and quickly that we have to devote time into that area. So what do we see again in transportation when we compare these across the three themes we have? So AI applications vary across the cities, and especially the speed of implementation or what gets implemented first. That's really up to the governments to address very specific transport challenges they have. Generally speaking, all of those who have deployed it perceive it as improving urban mobility for the better. Industries have primarily released AI on traffic control, so a lot of data that has to get processed. Public transportation management, especially in the larger capital cities, we see happening to improve efficiency, coordination. And generally, they're speaking in the transportation field, they rate it positively. And here we're looking at, again, the most deployed cases so far. In terms of people, we've again seen a very evenly split. They are open if they've seen it, if they've seen the results, if it's actually improving, but they're still very skeptic about how their images will be used and how their data will be protected. Okay, this was basically the first half of my presentation where I gave you the current state of knowledge on the cities, how they implement AI, how they use intelligent transportation systems. And here is a deeper dive into autonomous mobility. And it's a nice retrospect because that study was done about 5 years ago with partners here at Michigan State University, where autonomous vehicles and autonomous mobility was just starting to surface. And we focused this time on buses and people. So basically, do you want autonomous mobility? Because back in the day, the discussion was primarily about cars, not really public transportation. And so here, back then, it was basically also saying three major claims in the literature were transportation challenged populations. So those are primarily either someone who had a disability, the elderly, if they lose their driver's license, they can't go anywhere, and those were unwilling or unable to drive. So, for example, teenagers or kids, they can't drive. Or someone who is blind will have very hard challenges and can't drive at all. So these were the ones that was cited in the literature of why autonomous vehicles should be used. And then the question was, are those really being helpful to those who are vulnerable or socially excluded? And so we looked at public transit. We looked at several public transit companies in Michigan. And we looked at those with less attention paid to those who are actually dependent on it. So as a background in Michigan, you have, they call it the Great Tsunami. So you have a high elderly population in Michigan. You're very dependent on cars, on individual movement of people because the public transport network is not as broad as in Germany or in Europe for that matter. And so we looked at those in particular. And we're basically looking at, okay, how do you implement it and which public policy do you need? So we looked at first peer-reviewed papers again. And this is a model we set up, a taxonomy tree, where I'm not going to go too much into detail, but what you should take away from it, that in social mobility, rarely anything was done on the natural environment. So how does autonomous mobility impact our environment? Back then, there was nothing done in terms of emission reduction or space usage. And the other thing that did stick out to us, where the literature was primarily positive, except for one thing, and that was communication. So here's a skills that humans have. The communication was rated negative. So there were concerns about that actually, if you introduce autonomous mobility, you will get less connected to other humans. So the result was it was basically reinforced the status quo that we have, but there was always an underlying assumption that that mobility transition could actually be mastered. So there will be autonomous cars, there will be autonomous buses, and everybody's going to take those. So here we went then into Michigan companies, public transit companies across Michigan. So we looked at would people actually be willing to switch from a bus driver service, so you had a person in the bus who would drive you, to an autonomous system. We looked specifically at people with different disabilities because that was advertised in the literature. We looked at fixed route riders, so those who basically have a bus that always takes the same route versus demand response. So that could be Uber, it could be a taxi, everything that you go directly from your house to somewhere else. And then we looked at, hey, how good is the bus driver and what makes the bus driver possibly better than autonomous vehicles? So we looked at driving skills, professionalism of the bus driver, and his helpfulness towards his customers or her customers. So what we did was we went to 919 people in Michigan. So we surveyed 919 of those. It's a Michigan-wide survey of the usage of transportation currently and the likelihood to actually accept autonomous mobility. So that's a very abstract, hypothetical question. And then we went into onboard intercept surveys of 1,468 current bus riders, and we asked them about their willingness to ride while they were on the bus, changing to an autonomous bus driver and how it actually changed their perceptions. We had a very high response rate of over 80%. So what we found was basically, well, autonomous buses might increase the willingness to use public transport, but whether they do or not is not proven, because then we asked in our intercept survey, and 50% of those who are currently riding were very hesitant about riding an autonomous bus, whether they would actually stay there. And now going back to the demographics, when our current study finds, younger females are more likely to accept AI, we see here when we asked 5 years ago that actually younger males were way more likely to accept public transit and females, and now the people where we were specifically focused on. So the elderly, seniors, people with a disability were less likely to actually wanting an autonomous car. And so they rejected AVs for several reasons, except those who couldn't see. So those who basically had visual impairments to an extent they couldn't drive themselves, they were the only ones of everyone who had a disability to say we are more likely to accept an autonomous car. What we also found is that the riders' satisfaction with their bus drivers had no impact on the willingness to ride an AV. And so we found basically what would you do in that concern, and autonomous buses basically saying if you have only 5% of those surveyed, so these were out of the 919 we surveyed online, we only had 5% who rode. So you have a very small margin of those who actually rode. And that's when we went into the intercept surveys. And here we said fixed route riders, so those buses who take always a specific route, so can be programmed very reliably, they were more likely to accept AVs than demand and response riders. And they cited safety concerns on the one hand, so it is the crashes they were concerned about. It was more so the second one, the lack of a human in an AV. So to put this into perspective, so if you're in Michigan and it's snowing and you're a senior and you're trying to cross a parking lot to get to bus, they basically saying, hey, the bus driver can see me and that person will actually wait for me, compared to an AI who is on a schedule and it's just basically leaving even though I'm almost there. So this was another very valid concern. And then generally speaking, a distrust in technology that is very common among the populations in general, that new things are likelier to be rejected if you have no experience with them. And so here is a kind of a overview of what we found. We found older people were less likely to ride an AV than younger people, females less willing to ride than males, and those with a mobility disability were less likely to accept an autonomous vehicle, except those who couldn't see. Rider satisfaction with their drivers, again, no impact on willingness to ride in AVs, which was very interesting to us. It was more so that the personal relationship that the people had built with a specific driver, and that only came out in our qualitative section, where I said that's our primary concern. We want a person on that bus who will be able to basically help me strap in, or will get out of the bus and help me get onto it if, I don't know, the curb is a little bit iffy and it's icy. So it was more the person that is on the bus, not necessarily the driver. And so then what we looked at. So our recommendations were, given what we found, the policy in transport must reduce the gap in terms of reducing the socioeconomic divide and paying particular attention to those who cannot. The mobility impaired riders really don't believe and cannot comprehend the benefits of AVs that could bring. And public transit vehicles should be tailored to the rider's needs. So what we ended up recommending was you actually need a person on the bus, not necessarily a skilled driver, but it's more so that there's a person who is supportive and gives that empathy. So we also saw it in the first section where people were concerned if you need an emergency responder, or if you need personal help, if you need someone who understands the situation you are in and need physical help or need even emotional help, we would like to have that person on the bus. Then we said, okay, people that we looked at, so the elderly, people with disabilities, with access challenges, were not looked at extensively in previous research. So we said there's definitely a difference in how and when people adopt these technologies and how fast. So you need to look at those specific people. Then we looked at it that you have to approach autonomous vehicles as a trip purpose problem rather than a vehicle solution. So it's not that you need a different car, it's what do you need that car to do in that very trip and that very moment. And then you need more robust study designs to replicate actual real life experiences. So now we're getting better with virtual reality. So we're moving towards how close can we get to a person experiencing life with artificial intelligence. And of course, we are also seeing across the world implementation of autonomous mobility and gathering their real life data of what it actually means. One area that has not been studied is how children, and especially children, will benefit or will they actually from AVs. And you see here a picture of my daughter, also 6, 7 years ago. But I basically asked her, would you get into a car that drives itself? And she said, absolutely not, with a very convincing little voice. And I asked, why not? And she basically said, she is not you. So it's the same reflection, that the pattern that we see, that there is a human that has empathy, a human that we trust, that is not in the car or is not taking responsibility for our well-being. And so this is probably the move where we're going in. How do we get humans into the car? How do we get people to trust AI if they don't do it? And what do we need from AI? How can it support that transportation and mobility area? So we're basically saying in conclusion that we have different demographics, different needs. General tendency is if you want to implement it, primarily younger population groups are more receptive to new AI solutions. If you can't exclude the elderly, and you shouldn't exclude the elderly in a sense that you really need to go door to door and get to the heart of what do they need in mobility. And we have a duty to make sure they have their mobile needs met. That means they need to go to the doctors more often. They will need access to groceries. So how do we capture them if they're not willing to ride in an AV? And how do you implement it slowly and get everyone to accept that autonomous mobility might benefit their lives? And if they don't, how do you account for the human being in their lives continuously for social support? Okay, so these were the two primary sections of the presentation, and I'm very open to any questions you might have.